Hello, and welcome to another Make a Code Monday video. My name is Max Lupo. I'm a programmer at the Innisfil Idea Lab and Library. And the project that I have today to share is a arcade game project using the code editor arcade.makecode.com. And the game I wanted to make today was a kind of Dance Dance Revolution style game where you have to press buttons in time with a kind of falling animation, essentially a rhythm game. And so it's a pretty simple iteration of something like this, but this is what it looks like. Where you have your character and you need to press the buttons in time as they're falling. So, forward, forward, left, left, and any other sort of directions. The key is that if you press the button too early, you eventually switch back to the default animation, and then eventually you get game over if you don't, press the buttons at the right time. And so the key thing is that I wanted to make sure that the game did not just let you hold a button down as an image was falling, and then you would get that point anyway because you were holding the button. The whole point of a rhythm game is that you are able to press those buttons in time and not before and not after. All right, let's get started. So here we are at arcade.makecode.com with a already started project. And as I was saying, there's a character who changes directions. So that means the first thing we have to do is make our character. So under the sprites drawer, I'm going to set my sprite to sprite blank of kind player. This does signify our player, so that's perfect. This is the sprite kind. But for the image, what we're going to do is choose something from the gallery, not only just for speed, but also because part of how this game is going to work is that we are actually going to be comparing the images that are overlapping and make sure that they are matching. For the default stationary character, I'm just going to choose a standing character here and press done. And so there is our character in a black void just hanging out. The first thing I often like to do is just give us a background color. So under scene, set background color to nice bright pink. As you saw in the demonstration, I kind of want our character to be center bottom. So that means under the sprites drawer, we want to set my sprite position to an X and Y location. So again, of course, the MakeCode editor represents a simulator here with the origin point being in the top left corner at 0, 0. The numbers get bigger to the right and bigger as you go down. And so we can see that practically here in this little simulator of the simulator where we have a crosshair. We can choose an exact location. I'm going to get close there. Oh yeah, there we go. So I wanted 80 on the X coordinate because that's the middle of the screen. And then now here's where things get kind of funny. I want to have the characters fall from the top of the screen. I want to check to see if they overlap with our main character. And if the images match, then you get a point. If not, then you lose a life. The interesting part, or I think the interesting part, is that I want to choose these images that fall randomly. And I think the most fun way to do that is under the advanced kind of section here, under arrays, we're going to make a list of images, and that will choose from one of those images at random. And so set list to array of. The numbers aren't exactly what we want, but again, under the advanced section here, under images, we can just have kind of an image selection. So I'm going to duplicate this a bunch of times, a little burger here. You could do a falling burger game, that's totally fine, but for our purposes, we're going to change those images in a moment. So there we go. So set list to array of, well, let's see. We need a character facing to the left. I like that one, personally. We need a character facing the right, away from us, like that kind of walking away pose there, and then the character facing down. So again, all these directions correspond to the button that the player should be pressing on the directional arrow. I'm going to do this front one here. I think I like that better. Yeah, great. Okay, and then since this is a game where we can lose lives, let's just set some lives. So under the info drawer, we can set the number of our lives to 3. So that's pretty much it for the onStart block. Nothing really much happens here. You see we have our hearts now for our lives, but our character is still there stationary. Let's maybe make the first thing we're going to do, make it so that our player can face these directions that we have here. For this, we're going to use the controller. So we need the controller drawer and on A button pressed. Maybe I'll just duplicate those as well to our little kind of controller map here. The fun thing with a block-based editor is that you can kind of arrange your code in a way that actually makes kind of, I don't know, logical sense for how it's maybe mapped out in space in a way. So here's my kind of representation of the buttons: up, left, right, down. And to make it make more sense for you as you're editing the code, you can arrange it, you know, up, right, down, left in that same configuration. And so what are we doing with these button presses? We're very lucky that MakeCode has this nice, lovely sprites drawer, and we can just change the image of the character. And so under the image kind of section in that category, we can set my sprite image to something. And so we can set that, you know, to a duplicate of one of these guys here. So here's our up image. I'm going to make sure that pops right in there. I'm not just duplicating because I'm lazy. I'm duplicating also because I want to make sure these are the exact same images, because the whole functionality of the game is making sure that the images are checked to be the same. And so we'll just keep on doing that. I'm going to duplicate this. I guess I can just duplicate the empty one. So we want the right image. That's this character here. Duplicate that. And then the down-facing image over there. So far, so good. Our character changes their direction when we press the button. Pretty snazzy. Of course, they kind of just stay there. And again, the whole point of a rhythm game is that you're able to press the buttons just in time. And so, you know, you can send me a letter if this isn't the perfect way to do this, but a perfectly serviceable way to do it is under the loops drawer, we can just kind of make a little pause, short pause, maybe of 500 milliseconds. The longer this pause, the easier your game, because this pause will signify the amount of time your character will keep facing that direction. Then after they're done facing that direction, we're going to just set them up to face in their kind of default forward vibe. So now when you press the up button, they face up and they go back to default. So we'll have to do that for all the other ones. So I'm going to duplicate this. Pause. And then duplicate our reverting back to normal image. That's the same one for all of them. So now all the directions will revert back to normal after a 500 millisecond pause. Maybe that's a little on the long side. Maybe it's a little too easy of a game, but it's a good way to get started. So now we need characters to kind of stream from the sky, from the top there, and hit our player. To create the falling characters, we can use the game drawer and the on-game update every 500 milliseconds. There are many ways to work with timing. This is probably the simplest way. So on-game update every, let's say, 1 second or 1,000 milliseconds. The next thing is kind of just the way I like to do this, or the way I think is kind of interesting. We're going to put an if block in here. And to add some more degree of kind of variability, because we don't want it to be, you know, just 1 second, one thing falls. To make it a little more random, the game drawer has this really fun block. The math drawer, both purple. The math drawer has a really fun block called, I guess, %chance. And you could, you know, work out some other code to do things kind of like rolling a dice, some probability. This block makes it very simple, maybe too simple, but still pretty fun. So every second, I want something to fall from the sky every 2 out of 3 times. So 66% of the time, something will happen here. So the if block says, if whatever's in here is true, then do what's in the opening. Well, if I roll the dice, you know, there's a 66% chance that this will occur, is what this if block is now doing. another nice simplification tool in MakeCode Arcade. Under the sprites drawer, there is a set projectile to come from a side. It's pretty handy, I think. The projectiles come from a particular side with a particular velocity, and they destroy themselves once they leave the field, which is perfectly fine. The kind of fun part, and maybe what's tricky about this particular course, is working with this list. We want to pull a random item from the list, and we can do that, again, in all sorts of ways. Here is one of the ways to do it. We are going to, first off, go to our arrays drawer and get a value at an index. And so lists begin at index 0, and so that means the numbers correspond to the images such that this is number 0, number 1, number 2, number 3. And you can see that kind of plays out there. So, they're all 0 right now because there's no randomness yet. So all that character is the same, all that character stream. And this is where we get to use the math drawer once again. So the math drawer, we can just pick a random number from 0 to 10. The 10 should immediately give us an error, or as soon as a number above 3 is selected, we'll get an error, I hope. There we go. So the program error, image is undefined. Perfect. That just means that the random number selected was greater than 3. The list has no values above 3, and so that returns an error as a result. So pick your random number from 0 to 3. Perfect. And then we want our characters that are coming from the top just to kind of flow straight down dead center. And so that means we only want a y velocity. So I can delete that there. The velocity x is no longer required. And then, of course, one last step. We'll see them there streaming down. One last step, we want to set our position of these variables. So we got to change this to the projectile. And we want to set that just to be x80. That's the center of our screen again. So there we go. They carry on with their given velocity, their vy, and they move down the screen, starting in the middle, which is perfect. There are many other ways you can introduce more kind of randomness into your code. There's no reason that it has to be 50 pixels per second down. That could also be kind of a random number, but for now, this is perfectly fine. Just for some additional visual flourish, under the sprites drawer, we can take a look at some of the effects. So we want to add a little effect for each of our projectiles. Let's say our projectile here wants a confetti effect. The default is 500 milliseconds, which is kind of a lot of confetti. Feels like that's a lot of confetti. So I'm just going to turn that down to 300 milliseconds. Okay, so everything works in our game except that there's no way to interact with the projectiles. So that is, of course, the next thing, but not too shabby. We can, of course, change directions, which is fun as they're falling, but nothing really happens. So in our little open area here under the sprites drawer, we're going to pull up a overlap. The overlaps in MakeCode Arcade are a way to detect if two sprites have collided with each other, and it does that by finding the first non-empty pixel in the image, and when that hits the other non-empty pixel of the corresponding image, it signals that an overlap has occurred. Our overlaps can occur with different kinds of sprites. So the kind player is our main character, and then the other kind is the projectile. And so you can have many different types of overlap blocks if you have many different kinds of sprites in your game. This is all we're doing for today. So we just need one sprite of kind player and another sprite of kind projectile. Okay, so here's where our logic game gets kind of kicked up a notch. Under the logic drawer, we want to if true, then else. And so what could be true? What could we be trying to figure out? Well, we want to see if the two images that overlap are equal to each other. I made an early mistake when I was trying to demo this program, and I was checking for equivalence with these comparisons here. But to check if two images are equivalent, we need to use a specific block from the images drawer. And so we want to pull the if picture is equal to image. This was a little tricky for me to wrap my head around, but this is what you got to do. Of course, there's no sprite named picture, so we get a very easy error to solve there. Under the sprites drawer, we have a block that returns the current image. So way at the bottom here, my sprite image. So this little block takes a peek into our sprite and then returns its image attribute for us for comparison. I don't want to just compare my sprite. In case there's multiple players, let's say, we can compare any sprite of kind player, which is quite nice. So nothing is equal to a blank image on the screen. And to facilitate the next step, we're just going to duplicate this one here. I'm very lazy, just duplicate that. And we want to see if the other sprite image matches. And so these two kind of placeholder bubbles here will come to signify any other sprite that matches that kind. So if the image is equal to the other sprite image, that's great. That means we're going to get some points. So that's under the info drawer here. We can change our score by, I don't like just changing it by 1. I like changing our score by 10. Makes it more meaningful that you're getting these points. And so our sprites overlap. When they match the image, we get a lot of points very quickly. And that's because we need to destroy the sprite once the overlap occurs. Otherwise, that action is happening the whole time. You can destroy the sprite, or maybe set that sprite to a ghost, which might be fun. For my money, let's destroy this sprite here. So under the sprites drawer, gotta look for our effects. We're gonna destroy the other sprite that we run into. And we'll do that, of course, with fire for a very short amount of time, because the fire is kind of very aggressive. Okay, great. So destroy sprite with fire for 5 milliseconds. Boom, 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 boom. And if I get it wrong, nothing yet happens. So that's what's next. Well, first things first, let's try this actually. Instead of destroying the sprite, if you get the wrong position, instead of destroying the sprite, let's set that particular sprite to be a ghost. So when I put the other sprite here, set it to ghost on. So that means the ghost attribute for any other sprite that hits this overlap turns on. And that should mean that they no longer detect collisions. And so to test that out, we're going to have to change life by -1. And so now, oh yeah, got some leftover bubbles there. So now ideally, it'll hit us, change our life, and then the other sprite will still be on the screen, but just to remind us how wrong we were, it'll stay there. So great, we're losing lives and getting game over, which is perfect. And so just to kind of show what's happening and why I think that's interesting, if I take this out of here and I just change a life, just like before when our score ran up to 140, now it'll immediately make us die, because without turning the other sprite into a ghost, this overlap is still happening every second that those two sprites overlap. So we're going to put that ghost back in there. So here we destroyed it, and here we just turn it into a ghost. So good, good, bad. Perfect. For a little more flourish in the game, we can add more sound effects than just game over. We could add, under the music drawer, a nice little ba-ding sound every time we get a point. And then let's turn that over to the big screen and see how it goes. Ding. And of course, if I press it too early, I switch back and I'm losing lives. And then I get game over. Great. So not bad. Maybe one last visual flourish. It's a little hard to know you got something wrong. So maybe under the scene drawer, we can shake that camera. So under the scene drawer, camera shake by 4 pixels. That at least gives us the opportunity to know or see that we've gotten something wrong. So we'll do kind of a big shake, 5 pixels for 200 milliseconds. And so let's see how that looks when we get it wrong. Perfect. So some feedback that the player had pressed the wrong thing goes a long way to helping your game and your player kind of communicate with each other. And so screen shake, game over. So not bad. The total view of the code kind of looks like this. There's a lot kind of going on. But in general, all we're really doing is choosing a random image and then checking to see if that overlaps with the input. To make the game harder, you can really easily make it more difficult by changing the amount of time that the player has to guess correctly. And so by changing this pause block, that means our image, the image of our character, will only stay that directional image for 200 milliseconds, so much shorter than before, which means they have to be more accurate in their timings. So there we go. So a much more narrow window. So if I press it too early, it goes back to its default and you lose. So not bad. That's a quick little way to make a rhythm game in the style of Dance Dance Revolution, though, heavily simplified. I hope you give it your best shot to make a game like this, and of course, share it with us if you do. Thanks so much for watching, and we'll see you next time.